One of the most important tools for a microbiologist is a microscope, and there are several different kinds of microscopes. For right now, I just want to give a quick overview of what microscopy is and talk a little bit about light microscopes. The microscopes you use in the lab, which that's where you're going to learn the parts and the way the microscope works is in the laboratory. But the microscopes you have are binocular, meaning that you look through two lenses, and I want you to get in the habit of using both of them. Unless you're blind in one eye, you should never use just one eye to use a microscope. Those microscopes are considered to be parfocal, meaning that once you get them into focus on one lens, they should be close to focus on other lenses. There's a high dry lens, which you never use oil with, and an oil immersion lens, which you always use oil with. Then we'll talk about resolution, magnification, if I can spell magnification, there we go. Relationship of light to resolution, and let's just go to the next slide. So magnification is basically enlarging of an image of a specimen. It has very little to do with whether or not you can see it better. Imagine taking a digital picture and blowing it up until you see the individual pixels. It's not going to help you see things clearer to blow it up too much. But magnification is necessary in order to be able to see the specimen. So a light microscope uses a series of lenses that magnify, and the resolution is the ability to distinguish two points together from each other. So you have better resolution of 2 points on your fingertips than you do on the back of your calf, because you have more touch nerve endings in the fingertips than you do on the back of your calf. So you could take a caliper or two sharp points and touch them together and be able to differentiate them on your fingertip. But if you had somebody touch them to the back of your leg, you might not be able to tell that that's 2 points. It would feel like one to you. Let's see. Resolution has a lot to do with how much light you have going through. The more light that hits your specimen, the better your resolution is. So as you increase in magnification, you need to increase the intensity of the light that goes through. You don't want to burn your eyes out on a scanning lens with the light being on high power. But when you get to the oil immersion, you should use as much light as you possibly can in order to get really good resolution. Light microscope has somewhere around 1,000 useful magnifications. Some of them can get up to 1,500, but 1,000 is what your microscopes have. And you can differentiate 0.2 micrometer resolution. If they were closer together, then you're going to get it to smear together and it'll look like one kind of blob that's merged together, where if they're further than 2 micrometers apart, then you can differentiate them. There's a couple of more terms, and then the types of light microscopes here. Empty magnification is increased size but no better resolution. So that's like digitally enlarging a picture. Unaided eye can only see about 1/2 millimeter. And then the types of light microscopes we have, the ones you use in the lab, are going to be the bright field. But there are also dark field, phase contrast, fluorescence microscopy, and confocal scanning microscopes. Confocal scanning laser microscopes specifically that I'm going to talk about.